surds are irrational numbers that cannot be written in the form a over b, where b does not equal 0. Some properties of surds when multiplying individual surds. So square root of a times square root of b equals the square root of a times b. And an example there would be the following. The square root of 9 times the square root of 4 would be the same as doing the square root of 9 times 4. Okay, so this is our first property. Let's just see if it works. The square root of 9 is 3, and the square root of 4 is 2, and I get 6 on the left-hand side. Square root of 9 times 4 is 36, and I get 6 on the right-hand side. So that's my first property of surds. Right. Second property of surds is that the square root of a divided by the square root of b equals the square root of a over the square root of b. So those two are identical. You're just writing it as a fraction. But here's the actual property, that it equals the square root of a over the square root of b. Now, an example with that could be, for example, if I want to do the square root of 36 divided by the square root of 4, I could write it like this, square root of 36 over the square root of 4. But what it's telling me is instead of doing each one separately, only if the numbers divide and give you a nice answer would you do this. That's the same as doing the square root of 36 over 4. Now let me just work out this side. Square root of 36 is 6, square root of 4 is 2. And over this side, I'd be doing the square root of what? So in other words, you can do it this way. Square root of 36 is 6, square root of 4 is 2. Or you could do it this way. 36 divided by 4 is 9. And just do the square root of 9, which is 3. And 6 divided by 2 is 3. In other words, you can work out each square root thing separately, then divide. Or you can divide the numbers first and then do the square root once. Okay? That's the second property. And the third property of surds is the square root of x all squared equals the square root of x squared, which equals x. Now what this is saying, actually someone tell me what this is saying, is telling us, look at the position of the squared, that if you square root a number and then square it, it's the same as squaring the number first and then square rooting it. Which method would you use? It depends on the number that you've got. If the number can be, if you can square root the number easily, you would square root it first. An example would be the square root of 36 squared. Now there is, actually no, I'm going to choose another one. The square root of 7 squared. Do you know what the square root of 7 is? Do I? It's between, tell me between which two numbers, but what's the square root of 9? And the square root of 4 is 2. It's between 2 and 3. Is it closer to 3 or closer to 2? Probably closer to 3, yeah. I can't do the square root of 7, right? But I could square the 7 first and then square root it. Does that make sense? Isn't that the square root of 49, which is 7? But if I looked at something like this, square root of 36 squared, would you ever square the 36 first and then square root it? No. Do you know what I mean? So with this one, I would not do 36 squared. Too hard. I would just say, yep, that one's just 6 squared, which is 36. So that gives you an example when to square the number and then square root, and when to square root the number first and then square it. Okay? In other words, it doesn't matter which way you do it. You do the way that's easiest for the question that you've got. Anyway, we can see now two ways that the squared and the square root are inverse operations. They undo each other. From your textbook, so simplify the following from exercise 219. Just going to do a couple of questions. Question 1R, so the square root of 125. See, you know what's really, you should know your square numbers, which are 1 squared is 1, 2 squared is 4. You know, I'm going to write them down here. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared, 36. 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. We could keep going if we wanted, right? But remember, one of the factors here that I choose for 125 has to be a square number. What number goes in nicely? Yes, so you're going to write this as the square root of 25 times the square root of 5, because the square root of 25 is 5. So it's 5 times root 5, which we just write as 5 root 5. Let's look at n, because it looks terrible. The square root of 243. Horrible. I can keep, I'm going to just write a few more. 121, 144. Don't think it's going to be any of those. What do the digits add up to? 6, 9. Means it's divisible by 3. Could be divisible by 9. Have a look. Could be divisible by 36. Maybe not. Try. 243. We know it's divisible by 3. See if you, on your calculator, try 243 divide by 9. What do you get? 27. Oh, but see, that is actually divisible by 9 as well. That means that if that's divisible by 9 as well, what does it mean that you can actually divide the first thing by? If you can divide by 9 and divide by 9, you can divide by 81. Does that make sense? So what you do, you find if it's divisible by 3. If it is, we know it is because the sum of the digits adds up to a number divisible by 3. So you do that and you say 27, but wait a sec, that's divisible by 9 too. So you could divide it by 9, divide it by 9. That is the same as dividing it by 81. So we've got the square root of 81 times the square root of 3. Got it? Which is 9 root 3. Now, whenever you're simplifying surds, you have to have, let's say I didn't do it like that, and I did it like this. That's done. Let's say I just thought it was divisible by 9. You would have had the square root of 9 times the square root of 27, wouldn't you? That's what you would have had. But then when you do it this way, you can do it this way, but you have to still simplify this. Square root of 27, 9 goes into 27, is 3 times the square root of 9 times the square root of 3, because the square root of 9 is 3. Now I want to deal with this, so it doesn't matter if you don't pick the biggest factors first, the biggest square factor. And then you've got 3 times square root of 9 is 3, and then I've got root 3, and we're multiplying surds, multiply the whole number bits, and you multiply the surd bits, but there's only one surd bit here. So there are 2 ways of doing this. As long as if you were doing it the second method, you keep going, it'll be okay. All right? Simplify 7 root 40. So start with your square numbers there. 4, 9, 16, 25, 36. Got to stop there. Which one? Yeah, 4. So that is 7 times. So keep the 7 out the front, times the square root of 4 times the square root of 10. When you break the 40 up into your 2 factors, try and put the first one that you choose, try and make it the square number. So this will be 7 times, square root of 4 is 2 times root 10. Now root 10 is root 5 times root 2, but root 5 and 2 are not square numbers, so you can't simplify it. So what do we get? 14 root 10. So if you were to ever give an answer as 7 root 40, that is not simplified. You have to simplify your answer. Now the next one. Well, we've got a few possibilities here. It's definitely divisible by 5. I don't think it's divisible by 25 because, how do you know it's not? Because what's 25 times 4? 100. 100 and 100 and 100 and 100, that's 400. Whoa, very good. And you know what? Is it divisible by 3? It is. You know how you know? Guys, we've got to go back to year 7. A number is divisible by 3 if the sum of the digits is divisible by 3. So what's 4 plus 0 plus 5? 9. So what you can do, you can divide that by 3 on your calculator. What do you get? So divide by 3 on your calc. What do you get? That's divisible by 3. So divide by 3 again. What do you get? So this is what you'll be doing. You don't have to write it down, but you'll be going like this. That's divisible by 3, right? So you divide it by 3, you get an answer. You can quickly add up the digits again. They add up to 9, which is divide by 3 again. So now you know it's divisible by 9. Oh, 45. That's divisible by 9, and there's your 81. Can you see? If you divide, what's 3 times 3 times 3? 3 times 3 is 9, 9 times 9 is 81, there's the 81. Or if you know your square numbers, if you can see that 81 goes in there, that's great. But if you divide it by 5, I think you get 81 anyway. You know how it was divisible by 5? The other way is, I know that's divisible by 5. What do I get when I divide by 5? 81, great, that's a square number. So yes, this is the long way. This is a good way. So looking, how do you know to try 5? I know 5 is not a square number, but that's okay. Any numbers ending in 5 or 0 are divisible by 5. Okay? So divide it by 5, just try that, potluck, great. 81 is a square number, fantastic. So it's 8 times, don't forget the 8. 8 times the square root of 81 times the square root of 5. Okay, so it's 8 times square root of 81 is 9 times root 5, which is 72 root 5. Okay, so that's simplifying when you've got your surd and a whole number in front. Question 3 is to write as a single surd. So you say to yourself, where did that 12 come from? Let's look back here. I'm ending up with 5 root 5. Where did that 5 come from? It came from the square root of 25. So you're sort of working backwards to write as a simple surd, as a single surd. So here you say, where did the 12 come from? Square root of 144 times the square root of 7, and you will need your calculator obviously to do that. Okay? So square root of, so you just do, which is, you know, you can multiply those two numbers together and write it as a single surd. You don't have to show that middle step, okay? So what's 144 times 7? 1008. 80. No, it ends in 4. 1008. It ends in 8. So you might see question 4 is identical to question 3. They want 8 root 15 written as a single surd. But you'll see it written like this. So evaluate x if root x equals 8 root 15. So we just say that 8 root 15 equals, where did the 8 come from? Square root of 64 times square root of 15. We know from the properties of surds that we can multiply the 64 and the 15 together. You don't have to show this step that I've just written. But 64 times 15 is 960. Now, is it in that form? So therefore x equals 960. Okay.